Hi, in a previous lecture we used a circuit like the one that we're looking at here. It contains a button and an LED, and when I press the button the LED would come on. In that lecture we used a function, a digital read function inside the loop to read the state of the button and then control the LED. What we'll do in this lecture is, instead of doing this reading of the button state inside the loop, to actually create an interrupt, connect the button to an interrupt, and then when the button is pressed, the interrupt fires, it stops the ESP32 from doing whatever else it might be doing at that point in time, and take a reading of the button and then write a new value to the LED. So this is important because, as much as possible in good programming practice, is to not constantly pull for things like button states inside the main loop, but assign those things to interrupts in order to make more efficient use of the hardware. So that's what we'll do in this lecture. In terms of the hardware and the wiring, things are very simple. You've seen this before. We've got a push button that is connected to GPIO 25, and you can attach interrupts on any GPIO. So this one is attached to GPIO 25, and then the other pin of the push button goes to ground. I chose not to use a pull-up or pull-down resistor in this example, and instead of that, we'll use an internal pull-up. I'll show you how to do that in code in a minute. And then for the LED, we've connected the anode via the resistor to GPIO 32, and the other end of the LED and the resistor goes to ground. Let's have a look at the example sketch to learn how to implement an interrupt-driven programming in ESP32. It's very similar to what you would have done in the Arduino, with the difference that the Arduino Uno only has 2 pins that you can use to attach external interrupts to, where this is not a limitation in the ESP32. So here's the sketch, and up here I've got further reading that I encourage you to do. An interesting reading is the interrupt allocation. The link for that is this one here. So here you can learn about the way that interrupts have been implemented in the ESP32. As you know, the ESP32 has got 2 cores, and each of those cores has 32 interrupts, various priority levels, and there's a lot of details here that are useful to know. I'm going to leave this up to you to read. Another one is the technical reference. So this is this document here. Just jump to section 2, interrupt matrix. It's this one here. So it shows you again how interrupts are built in the ESP32. So we've got all up 71 peripheral interrupt sources and inputs, and we've got 26 peripheral interrupt sources per CPU, etc. It's a lot of details here. I'm going to come back to this document later, and in particular this header file, because we'll be using the attach interrupt function in our sketch. So I'll keep this handy and open for the time being.